Good evening. Today's quote is by Aristotle. Quality is not an act, it is a habit. Quality is not an act, it's a habit. Today's word is zenith, the highest level or degree attainable, the highest stage of development, the highest point that the sun or moon reaches in the sky directly above you. Uh, in the last lecture, we started the topic complex number. Now, what is a complex number? A number which is of the type a plus ib, where a and b are real numbers. This is a Greek alphabet, epsilon, epsilon, and it stands for belongs to. So a and b, they belong to set of real numbers. And what is I? Iota, IO, TA, again Greek alphabet, imaginary unit. So I is root of minus 1. Now I square is nothing but what is square of minus 1? Rather, what is square of root of minus 1? Minus 1. Remember, root of minus 1 is not real number, and that is why we have to define it specially, and we call it as an imaginary unit. What will be I cube then? I cube is nothing but I square into I, but I square itself is minus 1, so it is minus I. What is I raised to 4? I raised to 4 happens to be the square of I square, but I square is minus 1. Minus 1 square is nothing but plus 1. So you should know about this. Now, when I say a plus ib, a is called as a real part, b is called as an imaginary part. Some students think that imaginary part is imaginary. No, as b is attached to imaginary unit, it is called as an imaginary part. Okay, but it is a real number only. Now, every real number is a complex number. So I can call set of complex number capital C as the universal set. Uh, we have begun with set of natural numbers, next set of whole numbers, then integers, rational number, irrational number. Real number is the superset of earlier sets, but now set of complex numbers is the superset, because every real number is a complex number, but every complex number need not be a real number. Okay, so this is about complex number. Then we discussed equality of two complex numbers. Two complex numbers are said to be equal if and only if their real parts are equal and imaginary parts are equal. How to add one complex number to other? Add real part to real part, imaginary part to imaginary part. Then how to subtract one complex number from other? Same, subtract real part from real part and imaginary part from imaginary part. How to multiply a complex number by a scalar? Multiply both real and imaginary parts by that scalar, that is constant. Then we have discussed product of two complex numbers. In fact, it is applicable for more than two complex numbers also. Now, division of complex number is important. Suppose we are asked to divide 1 plus I by 3 minus I. So division by a non-zero number, complex number, is defined as to divide 1 plus I by 3 minus I means to multiply both numerator and denominator by the complex conjugate of denominator. Now, what is that conjugate? Conjugate of a complex number is a complex number obtained by changing the sign, SIGN sign of imaginary part. Now, what is imaginary part? Minus 1. Make it plus 1 to get conjugate. In short, we write this with real denominator, purely real rather. Okay, so this is how we divide one complex number by other. Exercise 1.1, third question, third part. Actually, the question is find A and B if. See, LHS and RHS are to be written in which form? A plus IB, so that we can equate real and imaginary part separately. So real part is 2 into a plus b on LHS, and imaginary part is just a plus b. RHS is already in that form. Then you have to actually write this. So you get first equation as what? 2a plus b equal to 1. On equating imaginary parts, please do not write a plus b into I equal to 10 plus 2a into I. That is not wrong actually. But when you say imaginary part, you should not include I, because I is an imaginary unit, remember. So this is the second equation. Add them to get a equal to minus 3. Put this in any of the two equations to get b equal to 7. So this is the final answer. Right now. Fourth one, ABI equal to 3A minus B plus 12I. Don't say there is no real part on LHS. Basically, it is purely imaginary with zero real part. So write 0 plus ABI equal to 3A minus B plus 12I. Equate real part and imaginary part separately. You should not write in this manner, but this stands for on equating real and imaginary part separately. See, writing on slate is challenge. So please excuse me for this. um, so 3a minus b equal to 0. So b is 3a and ab is 12, but b is 3a. So this becomes a into 3a equal to 12. So a square is 4. Some students have taken only positive root. No, here you have to consider both the roots, plus minus 2. Now when a is 2, b is 6, and when a is minus 2, b is minus 6. So these are the answers. You may write this separately. Answer: a equal to plus minus 2, b equal to plus minus 6. Fifth one, 1 upon a plus ib is 3 minus 2I. You may ask me, sir, can we cross multiply? The answer is yes, but I'll tell you simple method. Take the reciprocal, right? So if you take reciprocal, then you get a plus ib equal to 1 upon 3 minus 2I. Now to divide 1 by the complex number 3 minus 2I means to multiply both numerator and denominator by the complex conjugate of denominator, which is 3 plus 2I. So numerator is 3 plus 2I. See, denominator will always of which type? First minus second into first plus second, square of the first minus square of the second. I square is minus 1. So a plus ib becomes 3 plus 2I upon 13. Split numerator. So 3 upon 13 plus I 2 upon 13. You have to write this on equating real and imaginary parts separately to get what? A equal to 3 by 13 and B equal to 2 by 13. Sum number 6, a plus ib into 1 plus I is 2 plus I. One method is just open brackets on LHS and so on. But the shortcut method is rearrange the terms to get a plus ib equal to what? 2 plus I upon 1 plus I. Now to divide one complex number by other means to multiply both numerator and denominator by complex conjugate of denominator 1, which is 1 minus I. Now in the numerator, open the brackets to get this. What is I square? Minus 1. So 2 minus 2I plus I is minus I. Minus I square is plus 1. Denominator is 2. So a plus ib is 3 upon 2 plus I minus half. Now you have to write this stands for on equating real and imaginary parts separately. Remember, this is not the standard short form. Okay. So what is a from this? 3 upon 2. And what is b? Minus half. Now, fourth question. Express the following in the form a plus bi, where a and b are real numbers and I is an imaginary unit. State the values of a and b. First is for homework. Answer is minus 4 minus 3I. So what is a? Minus 4. What is b? Minus 3. Now second, 1 plus I into 1 minus I raised to minus 1. Raised to minus 1 means reciprocal. So it is 1 plus I upon 1 minus I. Now to divide one complex number by other means to multiply numerator and denominator by complex conjugate of denominator. What is that? It is 1 plus I. So 1 plus I upon 1 plus I. Now numerator is basically square of 1 plus I, which is 1. What is a plus b bracket square? A square plus twice ab plus b square. Simple. Upon denominator is always of which type? A minus b, a plus b, which is a square minus b square. Right? So this is 1 plus 2I minus 1 because I square is minus 1. Denominator 1 minus minus 1. Please use bracket. So numerator happens to be 2I. Denominator is also 2. So you get I. But we have to write answer in which form? A plus IB. So I is to be written as 0 plus I. See, then only you'll get full marks. You are asked to find the values of A and B. A is real part, which is 0. Some students write B equal to I. No. I means 1I. Okay. So A equal to 0, B equal to 1. Third one, it is I into 4 plus 3I upon 1 minus I. Open the bracket. So 4I plus 3I square. Again, I square is nothing but minus 1. So it is 4I minus 3. To divide 4I minus 3 upon 1 minus I means to multiply numerator and denominator by conjugate of denominator, which is 1 plus I. Again, open the brackets. Replace I square by minus 1. You get this minus 7 plus I upon 2. If you write this as the final answer, you won't get full marks. You have to split numerator. So minus 7 by 2 plus I into half. So what is A? Minus 7 by 2. And what is B? Half. Very good. All the students have written, rather typed correct answer. Good, good. Next one. 2 plus I. I think I should give this for homework. Now you will say, sir, but we have started and we have finished 50%. So complete that in that case. I'm writing final answer. You will ask me, sir, how can we get final answer just by writing the sum? I have copied this from the textbook. This is the answer. Okay. This is for homework. But if you have started, you can complete that. No issues. So A is 3 by 10. B is minus 1 by 10. Okay. There is one good suggestion from a student. He says, sir, please tell us which are the sums for homework in the beginning only, so that we will not start that. Yes, good suggestion. So this is for fourth one right now. So 1 plus I upon 1 minus I square. So this is, see, there are two methods. You may say, sir, within bracket we will simplify. That is also correct. But I'm writing this directly. 1 plus 2I plus I square. Because what is A upon B bracket square? A square upon B square. In the denominator, 1 minus 2I plus I square. So 1 plus 2I minus 1 upon 1 minus 2I minus 1. So 2I upon minus 2I, which is minus I. I'm sorry, I gets cancelled. How come minus I? I'm sorry. 2I upon minus 2I is nothing but minus 1. But remember, it is to be written as minus 1 plus OI, 0I rather. So what is A? A is minus 1. And what is B? B is nothing but 0. Right now. Very good. Sum number 8. Sum number 8 is for homework. 8, 10, 8 and 10 for homework. So fifth will be followed by sum number 6. Write down 3 plus 2i upon 2 minus 5i plus 3 minus 2i upon 2 plus 5i. Now you will observe that denominator in the first, rather denominators are complex conjugates of each other, right? So why to consider this separately? Say 2 minus 5i into 2 plus 5i is LCM. So tell me, what is numerator? 3 plus 2i into 2 plus 5i. I hope you know how to add two fractions. Within fraction of a second, you should tell me that find LCM, divide common denominator by denominator of the first, multiply it by numerator of the first, and so on. Oh, I'm sorry. Yes, open all the brackets and tell me what you get. So 6 plus 59 plus 4i plus 10i square plus 6 minus 15i minus 4i plus 10i square upon 4 minus 25i square. Next step, this is nothing but see, I'll do one thing. 15i minus 15i cancel, plus 4i minus 4i cancel, right? So this is 6 plus 10 into minus 1, okay, plus 6 plus 10 into minus 1 upon 4 plus 25, okay. So this is 12 minus 20. So is it minus 8 upon 29? But we have to write this as plus 0i. So A minus 8 upon 29 and B equal to 0. So this should be the answer.
Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, z, omicron, pi, rho, sigma, tau, epsilon, phi, chi, psi, omega. Sir. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, z, omicron, pi, rho, sigma, tau, epsilon, phi, chi, psi, omega. Sir. Zeta, eta, theta, iota, kappa, lambda, mu, nu, z, Omicron, Pi, Rho, Sigma, Tau, Upsilon, Phi, Chi, Psi, Omega. Sir.
1 plus I raised to minus 3 is 1 upon cube of 1 plus I. Now it is a plus b cube, a cube, plus thrice a square b, plus thrice ab square plus b cube. Now I is root of minus 1. So it is I square minus 1. What is I cube? I square into I. But I square is minus 1. Minus 1 into I minus I. So on simplification, you get 1 upon minus 2 plus 2i. Now multiply numerator and denominator by complex conjugate of denominator. So minus 2i upon same. So numerator is minus 2i. Denominator is 4 minus 4i square. I square is minus 1. So 4 plus 4. So minus 2 minus 2i upon it. Split numerator. So minus 1 by 4 plus I minus 1 by 4. So what are the values of A and B? Minus 1 by 4 each. Next, I already told you it is for homework. I'll give the hint for sum number 8. Basically, it is 2 plus what is root of minus 3? You have to write this as 2 plus 3i. And what about denominator? 4 plus 3i. Okay. Now you know how to divide one complex number by other. I'm sorry. I'm sorry. करेक्शन आहे बघा सगळ्यांनी. अरे ते 2 प्लस रूट ऑफ मायनस 3 आहे ना. व्हॉट इज रूट ऑफ मायनस 3? रूट 3 into root of minus 1. Root of minus 1 is I. Now this is correct. I'm sorry. Answer है 11 by 19 plus 2 root 3 upon 19I. पुढचं बघा कळतंय का? Check the values. आता एक जण म्हणतो सर हाऊ कॅन आय टाईप रूट 5? टाईप ROOT 5. सिंपल. येस ईशा बरोबर आहे. ओनली ईशा हॅज रिटन द आन्सर. Sum number 8 for homework. See, it is 2 plus root of minus 3. Root of minus 3 is what? Root 3 into root of minus 1, which is I. So 2 plus root 3i in the denominator, 4 plus root 3i. This is the answer. Now sum number 9, root of minus 4 is root of 4, which is 2, into root of minus 1, which is I. I have written this directly. Hope you will not take minus sign inside this radical sign. Root of minus 9 is root 9, which is 3. Root minus 1 is I. Here a plus b into a minus b, which is a square minus b square. So what is the answer? A equal to real part 14 minus root 5 and b is nothing but 1. Right down. I already told that sum number 10 is for homework. Answer is 13 plus 0i. Sum number 11, 4i raised to 8 minus 3i raised to 9 plus 3 upon 3i raised to 14 minus 4i raised to 10 minus 2. Equal to, see, I will write a plus ib. Okay. Now I will find these values separately. Means what? What is I raised to 8? It is I square raised to 4. You may say I raised to 4 square, same thing. Now minus 1, if index of minus 1 is even, answer is plus 1. Okay. Now we have already obtained I raised to 8. I write this as, one student is saying, can we take common? We cannot, because plus 3 is there in the numerator. In the denominator, minus 2 is there. So not possible. So 1 into I, that is I raised to 9. Then I raised to 10 is also there. Okay. You can make use of I raised to 9 for that, or I square raised to 5. I square is minus 1. Minus 1 raised to 5 is minus 1. And what about I raised to 14? It is I square, I'm sorry. It is I square raised to 7 minus 1 raised to 7, which is nothing but minus 1. I hope this is clear to you. And therefore, I can say a plus ib, we have denoted the number by a plus ib, is what? It is 4 into 1, substitute the values, minus 3i plus 3. What about denominator? 3 into minus I. Oh, I'm sorry. It is I raised to 11. Oh. Let me check. What about denominator? Is it 14 or 11? It is 14 or 11. I'm sorry. It is not 14. Please make the correction. 3i raised to 11 it is. Oh. I'm sorry. Now I have corrected that. Oh, so what about I raised to 11? I raised to 14 I have written, but it is of no use now. Let it be. Here I will write I raised to 11 is I raised to 10 into I. We have already obtained I raised to 10 minus 1 into I, that is minus I. Please make the correction. Denominator is 3I raised to 11. I'm sorry. 3I raised to 11. Rest part is correct. Okay. So it is 4 into 1 minus 3i plus 3 upon 3 into minus I. Okay. Minus 4 into minus 1 minus 2 as it is. So tell me what is numerator. It is 7 minus 3i. Just check this. Upon it will be what? 2 minus 3i. Yes. Yes. So a plus ib is this, multiply numerator and denominator by the complex conjugate of denominator, which is 2 plus 3i. Open the brackets. In the denominator, you can directly say a minus b, a plus b, a square minus b square. So 4 minus 9 I square is minus 1. So you get 23 upon 13 plus 15 upon 13 I. So what is a? 23 by 13. And what is b? 15 by 13. Sum number 5, show that minus 1 plus root 3i cube is a real number. Now what is a plus b cube? A cube plus thrice a square b plus thrice a b square plus b cube. It will be very careful. What is I square? Minus 1. What is I cube? It is I square into I, but I square is minus 1, so minus I. So substitute. I hope this is clear to you. Root 3i square. Root 3i square is 3i square. What is cube of root 3i? Cube of root 3 is root 3 into root 3, 3. 3 root 3. See? I cube. On simplification, you get 8 minus 1 plus 9, that is 8, which is a real number. So that's it for today.